did here. Yeah. So what's the question? Okay, so let me just give a small brief about what is a classification algorithm. When you take certain kind of problems, right, which are already defined, like say for example, if I give you a data set and the data set contains the patient details, right, the blood group and the sugar value of that particular patient, height of the patient, body mass index and all those, and there is a column in the data set which is called diabetic, whether yes or no. And if you want to train your machine to understand that if in near future a new patient comes whom we have already not classified as diabetic or non-diabetic, then that kind of a problem or a data set pertains to classification algorithm. But when you are currently working on a data set which is already not defined as diabetic and non-diabetic, let's say you do not have the column at all, and you want to group the patients basis similar characteristics or traits, then that is called clustering or grouping. Clear, Akhil? Okay. Anyone has any other question? Then I'll move forward. Okay, so now after we have gone through the clustering method, right? Now let's start with the first algorithm. And the first algorithm is k-means, which is the simplest algorithm for grouping individual data points, right, into certain groups so that you achieve your fundamental grouping as well as you achieve the personas within that. So let me give an example. Let's say you have got a data set which has multiple data points, right? And let's say, for example, they have two characteristics, x and y. X is 2 for A, 3, 4, 2, 3, 7, 2, 1, 2, 3. Now, if you see this, you have multiple data points starting from A, then you are having B, then C, then D, then E. Now, I want all of your participation while I'm explaining these concepts. Point A, the value is 2, 3. So similarly, if you create a graph, so this x and y can be any characteristic. So this is just a dummy example that I have taken. You can take any example like marks of a student. X can be marks in mathematics and y can be marks in physics. So you plot the value here and say, okay, so let me make a marking 3, 4, 5, 6, and 7. Similarly, I'll do a marking here. Seven. Right. Now, if you see here, if I want to mark the first point, it is 2, 3. So the first point is A. Second point is 4, 2. So 4 to B is here. Then 3, 7. Then the point is here. And this is C. 2, 1. The point is here. D. E is 2, 3. And the point is here, right? So, right? So if you see these points, right, imagine that these points are the group of students. So either you can mark it like this and this in a separate group, or maybe you can do something like this, right? And this without the overlap. Okay, so don't mind this overlap. And if I define three groups, so I have created three groups. Similarly, I can have something like this and the second group like this. But we cannot do it manually by ourselves. So we need to use an algorithm to create groups within that. Now, if you clearly understand the problem is to group certain similar data points basis the characteristics. So here, if you take x and y are two different characteristics, right? But let's say you create only one group, then there is no meaning of creating the group only. Why? Because and all are now present in one group. So you cannot differentiate between two entities. The reason why we do clustering is to find out the relationship between two groups, and elements belonging to one group should have a different set of features as compared to the elements that belong to the other group. Now, let's understand this principle. So we have this data set. I will just rub this out. So hope everyone who is viewing is able to understand the graph that I have created. I have just plotted these numbers on the left hand side to the values on the right hand side. Perfect. Let's understand one most important concept. I will just increase the thickness. Okay. Now let's play a small game. Let's take two captains. Captain number one, A, and captain number two is C. Let's select two captains. And what everybody should do basically is create a small matrix, and this matrix will have A, B, C, D, and E. And let's create a small matrix like this, and let me call this as distance matrix, DM, right? And I will write down A, B, C, and D. Now, can you all tell me, those who are viewing, what is the distance between A and A? 0, 0. So all the diagonal elements within this will become 0. I forgot to put E. Okay, done. Now, within this, can you please check what is the distance between A and B? So if I define A and B and I want to find out the distance, what is the equation? Equation of the distance is x2 minus x1 the whole square plus y2 minus y1 the whole square. And this is called Euclidean distance. Those who are listening to it, can you tell me what is a Euclidean distance? Is this equation that I have given, is it right? Great. So I want you all to fill this, right? So what is the first value between A and B? Root 5. What is the value? This is 2, this is 1, right? So it is 4 plus root 5, correct? So similarly, we have to fill all of these. Can you take up some time and fill all of these together and tell me the numbers? Guys, don't give wrong answers. I'm not calculating, that's why. Tell me the answer for CD, CD, CE, and DE. Okay, hope we have completed, right? Now, the next step that we have to do, so as now we have completed the entire distance matrix, let's go ahead and try and understand what has to be done next. We already chose that A is a captain and C is the captain, right? Now, let me create two circles. Now, can you tell me B is close to A or B is close to C? So let's say BA is root 5 and BC is root 26. Root 5, root 26. Okay, so this is A's group, this is C's group, okay, B belongs to A. Now let's go ahead. What is the next step? D is far away from A or it's more far away from C? Let's go with D. D is nearer to A or D is nearer to C? D is again nearer to A. Okay. What about E? This is the same, right? Now, if you see, C contains only one element, but A contains B, D, and E. Now, what we need to do after this particular step is to reiterate. Now, we should not choose the captain. The system should automatically choose the captain. So, how do we do that? So, A contains B, D, E, and C contains C. So, can you tell me what we might have to do next, right? So, if you see, if I want to create a new captain, what should I do? I have to take x of A plus x of B plus x of D plus x of E divided by 4, comma 3 plus 2 plus 1 plus answer. And this is how much? 6, 9, 9 by 3, 9 by 4, sorry, this is 4. So 9 by 4, comma 9 by 4. So now we have got two groups. New captain, let me call this new captain as F. I have created a new captain called F, and I will reiterate this entire process taking the new captain F and the existing captain C. Okay, let's see what is so how to know which value is closer to which. Okay, Harsh, it is very clear, right? So if you have selected two captains, A and C, so if B is the distance between B and A is the district matrix, right? From the distance matrix you have to get B and A is this root 5. See, A to B distance is root 5, and C to B distance is, you can check here, root 26. So which is bigger, root 26 or root 5? Root 26 is bigger, so C is far away from B, but A is closer to B. Correct, Tushar? Tushar, do you have any question? Okay. Hope you all understood this concept, and we hope everyone has understood this concept, and we will reiterate this entire process, right? Till the point that both the captains stabilize. Okay, so you can randomly select any captains that you want, and you'd only have to select when you use the word k means this k is the total number of captains. So here k is what? 2. So you can select k is equal to 3. So to select what should be the optimal value of k means has a method called elbow. So we will see what the method is, but this is the concept, right? So I think it would be better if I teach the method as well. So let me take one more. Okay, so what elbow method does is it uses as k, this x is k here, and there is something called as WSS. I will tell you what it is. There is a fundamental concept when we are talking about clustering. The fundamental concept is if you create 3 clusters, 2 clusters, any number of clusters, then the distance between the points that are within the cluster, within the group, which we also call as cluster, should be less, as less as possible, so that this group is dense. But when you talk about distance between 2 clusters, which is called as intercluster, it should be as far as possible because both of the groups should be very much distinct and the characteristics should not be very much similar. So what I'm trying to explain is points within a group should be very close to one another, but points of two different groups should be very farther than one another. This the distance between two groups is called intercluster, and distance within the points of one group is called intracluster. So within sum of squares basically will tell you the distance between these, right? So when these particular points. So what happens is you start at k is equal to 2 and you might run till k is equal to 100, right? So not for this example that I gave you, but imagine that you have got 10,000 or 1 lakh data points and you want to make 100 groups, right, within that. So what happens is at a point there will be a tip. So at this particular point your k, let's say, is equal to 3. Then wherever this elbow has come, so this looks like a human elbow, right? So wherever the elbow point has come is the best value. Now can you tell me, is this related to intra-cluster or intercluster distance? Correct. So whichever is less, it is that. Hope you all have understood the concept of elbow, right? Now let's try and understand the code one by one. But before I do that, I want you to read this carefully. I have anyhow explained it. I want everyone to read from here till here. Please complete that, and once you complete it, please say yes. So done reading it. Okay, so now let's try and understand each and every pointer. So, but before that, we have to understand what is this data set, right? So this data set basically is helping us to convert the set of universities into two groups, right? And there are a lot of different variables that are included, right? What are the variables? I mean, private A factor with levels no and yes, indicating it's a private or a public university. So there's a column which says private or public university. Second variable says that number of applications received, number of applications accepted, number of people enrolled. Now, basis this, what they are trying to understand and analyze is what kind of universities are very much related with respect to their characteristics. What are those characteristics? Number of applications received, number of applications accepted, number of students enrolled, right? Out of state tuition, right? Number of PhD faculties and all those student to faculty ratio. All of those details are present, right? So this data set is for multiple set of universities. So let's see one by one. So if you see here, right? We are importing multiple set of libraries. Pandas is fundamentally used for your data manipulations, creation of tables and all those. NumPy is more for numerical or mathematical calculations. Matplotlib and Seaborn are fundamentally used for plotting purposes, plotting, visualization and all those. So let's use pandas as, so it's written import pandas as PD. PD is a alias name of pandas. So short form, something like that. We use pd dot read underscore csv college data, index column is 0. So what it is trying to do is basically there is no index column within this. Index column means there is no specific column which says that this is row number 1, row number 2 like that. So when you write index column is equal to 0, it takes the first column directly. Now once you do df.head, you basically get the top 5 rows, right? Top 5 rows for this data set. So if you see this data set, right, all the university names are there, and then private, number of applications accepted, enrolled, and all those, grading rate, number of PhDs, right, and all those details are there. Going forward, when you do df.info, fundamentally you will get what is the type of data set that you are having. One is objects, floating values, integers, and all those. So if you see, right, 90% or 99% of these variables are all numbers. Okay. Next, we do a describe. So when you run a describe function, the system automatically understands which of these columns are numeric, and basis that it will give you some fundamental statistics. What is mean? What is standard deviation? What is the minimum value within the column? What is the maximum value within the column? And all the fundamental statistics like interquartile range. I mean, here it is giving you 25%, 50%, and 75%. These are quartile points, right? Next, let's go and understand and do some exploratory data analysis. So if you see here, they have taken two columns, room board and graduation rate. So if you go back to this data set, you have room board and you have next is graduation rate. So let's go back and check room board and boarding cost. So what is the cost of the particular student living there, right? And graduation rate is how many of the students graduate every year, how many of them join, and how many of them graduate. So if you see 146 accept, graduate, the percentage is very less. So if you see here, you have got X as room board and Y as graduated rate. And the values present within that are labeled yes and no. So this is not a labeled data set fundamentally, but we are just plotting to see how does it look. So if you see here, right, the graduation rate of a private university is far more than that of a graduate, than that of a public university, right? And similarly, if you see the room rate for private university is still higher. So if I convert this into two parts, so let me just copy this image, put it on Let me just remove this, paste it here, just expand this. So if you see here correctly, let me just split this into four parts. Now this is basically low room rate and low graduation rate. This is high graduation rate and low room rate. This is high graduation rate and high room rate. And this is high room rate and low graduation rate. So if you see these points right here, you have a slight mix of blue and orange, right, or light orange. So if you see, but the points on the right hand side are more related to private universities. So the room rate here, all these places are higher, correct? Now if you but the graduation rate is low. Here if you see, most of the cases room rate is also low and graduation rate is also. Those cases where graduation rate is high and room rate is also high, I see most of them to be a private university. So it is very clear that if you join a private university, you have to pay more, but the chances for you to graduate after 2 years is also high. This is what an understanding that we get out of this, right? Now let's move ahead and understand F undergraduate and outstate. Let's understand what it is. So this is 1, 2, 3, 4, 5, 6, 7. Let's say number of full-time undergraduates, and what is the other one that we were looking at? Outstate. Okay, I guess this is outstanding out of station tuition, right? So many people will not be from that particular state of United States. They might be from other other state, and there might be so many people. Some universities call out of state means if you're coming from India or China or any other country other than the US, then you have to pay the out of station tuition fee. So let's try and understand what is this. I'll just copy it back, paste it here. Okay, so now let's convert this again into a small group. I will just split this. So if you see that these are the portions wherein you have number of the out of station, I guess this is the fees, and this is number of full-time undergraduates. So those who pay less fees are those who are from the government university. That is very common, right? So if you see, this particular part is number of students at this range pay low, some number of students here pay high, right? So this is mostly private, and here there is not much, right? And here if you say that number of undergraduate students are not out of state, I mean the out of state people are very few here, and then they belong to government universities, and that is a very well known fact, right? So if you basically are an out of state student, you pay more amount, and you typically take a private university, because government university getting joining a government university is difficult. So similarly, we will go ahead and understand the next one. This is basically whether private or no, and what we are trying to do is student to faculty ratio. So if you see, in a private case, the student to faculty ratio is less, but whereas in government, the student to faculty ratio is more. So how do we read this is basically these are all the outliers that you see, right? And this is the minimum value, right, that system considers. This is the maximum value, and these are the outlier points. And this is your 25%, 75%, and the 50% mark, right? So if you see, it is between 11 to 15 for a private organization, whereas for government organization it is for 15 to 20, right? So obviously it is very clear that the student to faculty ratio means for how many students, how many faculties. So if you want to do a good business in education, then obviously you will take less number of faculties and more number of students. That's what this says. Going forward and percentage alumni. So let me just check that. Okay, so alumni who donate more. So if you see here, I guess those who are belong to private universities are donating more money, right? And here it is less. And let's go ahead and try and understand. Okay, so here basically what it says is there seems to be a private school with a graduation rate of 100% and more, right? If you see here, you find, so that means there is some issue with this data. So you need to clean that data very well, right? So once we do this kind of basic analysis, then we go ahead and move towards the actual k-means cluster. So as I said before as well, that sklearn basically is a package that contains most of the machine learning algorithms, right? So one of the machine learning algorithm within clustering that we are talking about. So clustering might not be a machine learning algorithm. It is more like an automation kind of environment. If you see here, k means number of clusters is 2 and maximum number of iterations. So as I explained here, right, this is one iteration. Similarly, you can have multiple set of iterations. So if you want to stop that iteration, then this, right? So rest of all are not much important. You just have to think of the number of clusters and the maximum iterations. Now next, you are dropping the column called private because the thing is it's a discrete column and we are not doing classification here. We are trying to group things together. Once we do that, what we do is we start to define the cluster centers. So as I said, how many captains we have selected here? We have selected 2 captains. So here this is captain number 1 and here this is captain number 2. So these are the 2 captains that you see. And if you next what we are trying to do is we are trying to do some analysis of the private colleges only. And here we are trying to do some analysis of the public colleges only, right? So we can clearly see that number of applications when you are a public university, the count is less. Here the count is more, right? So it's like that because most of the cases what happens is those who are out of station, they prefer more private universities, but because completion rate is high and all those. Next is if you see here, right, it tells you, it gives you a brief description. So if you read here, it says create a data frame with cluster centers with columns borrowed from the original data. Okay, so is it clear from this data frame which labels correspond to 0 and 1? Because what we are trying to do is if you have a private university and you have a public university, we are trying to segregate that and then run our clustering model. So if you see here, what is happening is we are creating a description. So we are just copying this description that was given here. This one, this entire thing, we are grouping them together and putting into a data frame. Then this will give you the list of all the column names. Then cluster centers will tell you that, okay, for 0, the cluster center is this, and for 1, the cluster center is this, right? And what are the labels? Labels means basically private yes or no. So we don't have to worry much about the cluster labels as of now. We are more interested within the variables that we are looking at. So variables like apps, accept, and all those things, right? Now what we are trying to do is there is no specific way of creating clusters, right? So, but we are trying to develop using k-means some methodology behind it. So now let's come here. We are trying to create a data frame called private, right? And all the private colleges will come together here. Once we do that, what we are trying to assess basically is that if I'm trying to group all of these, so let's not worry about these points, right? What we have to worry about is basically how many cluster groups have we created. So if you see here, when you write number of clusters is equal to true, what is happening is you have taken the entire data set, right? Have you dropped any of the data set, any of the rows? No, we have dropped one column and the entire data without worrying about which one is private or which one is public. We have fitted all of them into this k-means clustering, right? Did you understand what I'm trying to say? Hey all, let's start back, right? Uh, I want to give you a 5 minute assignment of basically trying to find out what are the different kind of use cases that we solve in clustering, and it has to be industry relevant. What are the each one of you have to give at least one use case, and it should not repeat. None of them should repeat. So take 5 minutes and try and find out. I mean, you can go on Google, right? Search and try and find out 5 use cases, right? I want just top five, right? So first five, whoever gives, it's done. But it has to be industry relevant. Do it fast. Is spam filter a classification problem or a clustering problem? So Rahul, good question. A classification problem cannot be solved using clustering, But using clustering, you can create the data set that fundamentally can be used for classification in future. So once you create those classes that are required, then you can go ahead and do that. Okay, so let's move ahead. We'll not typically go into this, right? So now what we are going to basically learn is fundamental to understand what is called propagation clustering. Okay, so I'll tell you what is the fundamental difference between k-means and affinity propagation. The main difference between both of them is that in k-means we are trying to find out obviously the distance, and basis the distance we are trying to say, okay, these two data points belong to one group, right? But what if you had some data point which had affinity to be a part of A but ended up being part of B? That means out of four variables, let's say for example age, weight, height and body mass index, three are very much nearer for group A. But because of the last column, let's say for example you take height, the height is very high, because of which that particular data point, rather than going into A, went into B. In such cases, can you tell me, basis logic, what can be done? Hope you have got my question. Guys, I need answers. I want you to read this particular paragraph clearly. I'll tell you the most fundamental difference between k-means is and affinity propagation is k-means you have to specify the value of k. Affinity propagation automatically takes the value of k basis the data it has. That's the most fundamental difference. But k-means is very good when you're talking about scalability. So if you take 1 lakh records, 2 lakh records, k-means can run. It is going to take time, but affinity propagation is not scalable. And let's say if I want to give examples with respect to use cases, k-means works very well, in a general purpose kind of a use case. Okay, where the cluster size is quite even. Even means, let's say, for example, not the one that we did previously, right? Even means here in cluster A also you have got 30, cluster B also you have got 30, something like that. And k-means is not good when you create too many clusters. Whereas if you take affinity propagation, multiple clusters can be easily created and it doesn't have any problem in that. And this affinity propagation is mainly used in computer vision, image processing, right? And various different biology tasks and all those. Guys, did you understand what is the fundamental difference between affinity matrix, affinity propagation, and k-means? First fundamental difference, right, between affinity matrix and k-means is, or affinity propagation and k-means is, affinity propagation works very well, right, for more number of clusters as well. But when you want to create using k-means, more number of clusters, it doesn't serve the purpose. Second thing is k-means you have defined the value of number of clusters. Affinity propagation will directly take from the data, right? These are the two most important and most uh, defined differences between both of them. The next is that affinity propagation typically is not scalable, whereas k-means is quite scalable in nature. Okay, so I'll repeat the key differences again, right? First and most important difference that we have to fundamentally look upon in both the cases is initially when you define the value of k means you have to define. So you have to always define the value of k when you're working on k-means. But if you're working on affinity propagation, you don't have to define the value of k. The system automatically takes basis the number of records. That is point number one. Point number two, k-means is scalable even if you give thousands of samples. Affinity propagation is not scalable. Just clearing that. Third difference, k-means works in general purpose kind of clustering, right? And you need to have even cluster size. That means you cannot have one cluster having only one entry and another cluster having 100 samples. You should not have. K-means doesn't work well with that. Whereas, even if there is uneven cluster sizes and more number of clusters, affinity propagation works really well. The third important point, this is not a difference, third important point is affinity propagation works in computer vision. Most of the computer vision use cases, you have affinity propagation or matrix, and in biological tasks. right? So these are the key differences. What I will go ahead and do is I have shared the code and stuff with Board Infinity, right? And they will put the details on Slack. What I want all of you to do is execute this k-means, right? And after that, in the next lecture, I want all of you to go ahead and explain these, run these concepts. And if you have any doubts within this, you can ask me. So we will do only these two in clustering, right? And next, we will go ahead and do the association. So next lecture, we will have association rule mining, right? So what I want you to do is basically go ahead. So I have shared this folder with Board Infinity. Okay. So what you have to do is go to machine learning, and within machine learning, go to clustering and dimensionality reduction. And within that, what you can do is you can take these two, execute it, and you have to tell me if you have any questions within that. And homework for all of you for the next lecture is implement dbscan and hierarchical clustering. Both of the codes are already there. You have to just go through the code and tell me in few sentences what is the difference between k-means, affinity matrix, dbscan, and hierarchical clustering, right? So we will share a small Google form with you, and you have to fill that particular Google form with the right answers and give it back. No, we will have few more classes. Okay. So thank you for listening to me. Let's complete that activity and we will get back in the next class. So all of you should complete that particular homework that I'm giving you so that I know how much you have gone through in this entire course. And after this course, we will have a small questionnaire that you have to fill up, and I'll see, how many algorithms you have learned, how did your Python go, and all those.